Session 30, we're going to take a look at inverse operations. One way of thinking of inverse are opposites. Uh, One other way of thinking is that one particular operation may undo another one. So you can think of inverse in that way as well. Now, addition and subtraction are inverses of each other, and multiplication and division are also inverses of each other. What do we mean by inverse here? What we mean by inverse is that one operation undoes the other. Let's take a look then at our first example here. 11 minus 4. 11 is the number we're starting with. We're going to subtract 4 from it. Well, since addition is the inverse of subtraction, we could turn right back around and undo that subtraction by adding the same 4 that we subtracted. And if we do that, do we get the same number that we started with? Well, of course we do. We get the 11. If we start with 11 and subtract 4, but then turn right back around and undo that by adding 4, we haven't changed the 11 any. This minus 4 and this positive 4 here will cancel each other out and equal 0. And that's because they're the inverses of each other. Positive 4 and negative 4 are inverses, as well as adding and subtracting. So here we can see that addition is the inverse of subtraction. Well, let's drop down to our second one here. This time we start off with 11 plus 4. 11 is the number we start with, and then we add 4 to it. Well, we can turn around and undo that addition by 4 by turning around and subtracting by that same 4 that we added. What is our answer here? What is 11 plus 4 minus 4? Well, that's 11 as well. Because if we start off with 11, then we add 4 and turn right back around and subtract the same 4 that we added, in essence what we've done is we've added 0. And by adding 0 to a number, we have not changed the original number at all. So we can see here in the first example, addition undid subtraction. And in the second example, we see where subtraction undid addition. So that's why addition and subtraction are called the inverses of one another. Well, the same is true with multiplication and division. Here we're going to start off with the number 11. And what we're going to do with that 11 is we're going to multiply it by 4. Well, after we've multiplied it by 4, if we turn right around and divide by 4, are we going to have the same number that we started with? And the answer is yes. If you want to calculate it out, you can. 11 times 4 is 44. 44 divided by 4 is 11. So we can see here by this one example that division is the inverse of multiplication. And the reason why is after we multiplied by a particular number, in this case 4, we can turn right around and take that and divide it by 4 and get us right back to where we started with. And one way perhaps of additionally visually seeing how this works, if you take a certain number and multiply by 4 and divide by 4, well, what is 4 divided by 4? Well, 4 divided by 4 is 1. Well, what is any number times 1? It's the number that you started with. So in this case, if we took our 4 divided by 4, that's the same as 1. 11 times 1 is still 11. So that's perhaps another way of visually seeing why division is the inverse of multiplication. That takes care of that one. In our last example here, we start off with a division problem. We have 11 divided by 4. Well, if after performing that, we turn right back around and now multiply by 4, will we get the same number, 11, that we started with? Well, the answer is yes, we will. But if you want to multiply it out, remember when you have fractions and you're multiplying it by a whole number, you can make a fraction out of that, 4 over 1. What is 11 times 4? Well, it's 44. That becomes your top number, your numerator. What's your bottom or denominator? 4 times 1 is 4. And then what's 44 divided by 4 equal? Well, that equals 11. So we can see here that multiplication is the inverse of division. So not only is multiplication the inverse of division, division is the inverse of multiplication. Addition is the inverse of subtraction, and subtraction is the inverse of addition. So here on the review sheet here, First bullet point, if one operation undoes another operation, these operations are inverses of each other. And we just saw examples of that on the previous screen. Addition and subtraction are inverse operations, as well as multiplication and division being inverse operations of one another. Since subtraction is an inverse of addition, whenever we start off with a number x, and then we add to that x a y, we can turn right back around and subtract that y from it and get the original x that we started with. Since addition is an inverse of subtraction, we can start off with a variable x, and if we subtract a y from it, we can undo that by adding that y right back to it, and what that'll leave us with is the x that we originally started with. Division is an inverse of multiplication. Because of that, if we have a particular number x variable and we're multiplying it by a y, and then we turn right around and divide by y, we get the original number x that we started with. And lastly, since multiplication is an inverse of division, if we had a problem that started off as a division problem, we have an x, and then we're turning around and dividing it by y, we can undo that by immediately turning around and multiplying it by the same y that we divided by. And after we've done that, we'll then be left with the x that we originally started with. Okay then, that'll end session 30.